Hey everyone. All right. Well, you know what time it is. I'm just configuring everything. Let me make sure everything's up and running. Don't have any mic problems or whatnot. While I'm configuring Book of Proof by Richard Hammock. The link is in the video description, so you can go and download it right now. It's part of the Creative Commons. So if you get the book, you can actually know the answer before I do because the answer is in the back of the book. So yeah, why don't you do that? Buy the book. It's a great book. Yeah, you put this on your bookshelf, and people are gonna think you do math, whether you do it or not. You know, it's bragging rights, but it's even cooler if you can do it. So let's get into it, shall we? All right, let me do this. All right, here we go. So I'll pop myself in here. There we go. Okay, good. So yeah, I'm up and running. Can take this off. We've made it all the way to section 1.7, Venn diagrams, exercises. Okay, and we are in 1.7. Okay, good. All right, so 1.7. Draw a Venn diagram for for the component of A, where A is a subset of the universal set U. Right. Okay. Need to think about that for a minute. A is a subset of the universal set. Okay, well, let's just try this. So let's say this is the universe. I don't know if this is going to work or not, but we're going to try this. I guess we can try any number of shapes. We can say something like this. Or let's see, we'll just put it right in the center. And say, draw a Venn diagram for A hat, where A is a subset of the universal set. Okay, this is A, and all together is U. And then we're going to say something like this. This is U, and this is A hat. Okay, so I think that, well, I don't know. Let's give that a shot. See if that's what they like. Because see, the problem with Venn diagrams, just thinking here, is that normally it's, like a Venn diagram, as I think of it, normally is a circle with a circle, right? But there is no overlap between A and A hat. They exist entirely outside of each other. So what happens is, another way to do it would be like this. Something like this. A hat. And we're just going to say this whole area is U. I suppose we can do it like that. But there is no, like in this case, they're exclusive. So what goes on in one is not affected by the other. Um, there is no overlap. In this case, the component A, the A top, has no A whatsoever. A and A top together combined creates U, the universe. Okay, so I'm gonna try this. Yeah, okay, that's fine. Essentially, that's what they did. Actually, they just shaded the A hat, but I explained that in the book. The only difference is they just shaded the component. So this is A. This is and then U is equal to. Okay, so that's basically what we're doing here. So you can draw it any number of ways, but that's fine. Book accepts that. All right, draw a Venn diagram for A minus B, and where it intersects with C. Okay, hold on. All right, oh, this is not gonna be easy. All right, this was 1. Let's say over here we're gonna be 3. We're gonna say, so we're drawing 3 circles. Mm, Okay, so let's see what we have here is A. Let's just give them A, B, and C. So the um the rule that the book has here, I'm gonna write it out here, is A minus B with an intersection of C. So, all right. So let's just go a little simpler here. Let's go one at a time. If let's just use color. Okay, this is A. This is B. Actually, you just use white. That's B. Okay. So basically, B takes its chunk out of A, and A continues to exist with what's left. That's called subtraction in this case. We're taking whatever is in B, even though if A and B were separate, they had nothing in common, like the universe. Hold on, I kind of drew this wrong there. That was incorrect there. A plus the component of A make up the universe combined. I said it correctly, but I drew a minus. If we are doing a negative, so we have this case A minus B. Okay, so B takes its chunk, whatever they have in common, out, and A remains with the rest. Okay, let's just do this way. So now, we're gonna say what an intersection looks like. We're gonna do that. Let's just do an intersection with A and C. Okay, so when they have an intersection, so this is union, this is intersection. Okay, so in this case, this is where they intersect. So here's a quick way to remember it. I need room. I need room. Okay. I'm going to show you how I mentally remember this. I mean, I don't really need to do this anymore, but okay, let me try this. Okay. So this is how I mentally would plot it in my head. So intersection or union. Oh, shoot. Not that. There. Okay. So we have union and intersection. So that's how I can mentally remember it. And you can too if you want. So it's just a fun, quick way. Okay, so we have A minus B, and then we have to say whatever A agrees with C. Whatever agrees with C between the two of them. So in this case, we're going to say A minus B. That happens first. So, okay. Hold on. Right. It would be, So let me see here. A minus B. Anything that's B is gone. So let's just start marking that. This we'll stick blue for B. So this is all gone. We can't use that because it's been a minute here. Oh, I have it right here. Why am I writing this twice? So basically, B takes out its chunk. So and then so then we just have whatever's left, the remaining A, and where it intersects with C. So the answer would be right here. Okay, and then we're just gonna get rid of this again because it's not relevant to this. I would say that this is the answer right here. The parts that remember we can't use anything in B. B took its share and then left, so we just have to use whatever's left in A, but it has to intersect with C. So that's how I read it. All right, let's see it. Okay, hang on a minute. Scratch. Book agrees. All right, good. All right. Continuing on. So what you got to take time on this stuff to really think about it. There we go. So yeah, it's just draw paint. There we go. Okay. Draw Venn diagrams for A union. Remember, parentheses, PEMDAS. Parenthesis comes first. It overrides all other mathematical functions. It has first priority. Even if it's like subtraction, that you have to do that first inside it. And okay, so the first one, there's a couple of here. Union of B intersection C. So they're going. Okay, so here's the thing. At the bottom, they have questions 11 through 14. They're drawing it like this. Which again, it doesn't matter how you rotate, which one you label A, B, and C. It's the relationship that matters. But because they're drawing it that way, when I look at the answers in the back of the book to see if I'm right or wrong, it's easier without me having to rotate it. Saves me that much work. Okay. Okay. B intersects C. Okay. And then the union of A, all of A, all of it, plus where B intersects C. Okay. And all of A. All right. That looks about right, I think. All right. Draw a Venn diagram. This is 5, by the way. All right. And A union B. It's getting cold out there, by the way. Work as a landscaper / handyman, but it's you get used to it. I rant on unrelated topics. Some people might find that infuriating, other people's entertaining, but just the way I am. So yeah, like I worked today till about almost 8 o'clock. I just have light systems, so I put them up where not every job you can work in the dark, but I use my light system, and yeah, for me, after all this time now, I'm so used to being outside that that's my default. Being inside is when there's no light outside or when I'm sleeping. So that's just me in a nutshell. I'm a landscaper, handyman, college student, skating coach. I'm not a teacher in the sense that I'm going to make lots of mistakes, by the way. I do all the time if you watch my other streams. So It just goes with the territory. But you get to watch me improve in real time, so that's cool. Um, A union B intersection A union C. Okay. Let's do it again. Let's see, we have here, here, and that was terrible. Okay. All right. So we have A, B, C. Okay. So first set is A union B. Okay. Um, and A union C. Where is A union B intersect A union C? Well, let's just take blue, and then we're gonna put purple on it. A union B. Okay. This is A union B. Is blue, and I'm gonna shade in hard on the purple when we do the final answer. Okay. This is A union B. Now, A union C, we're going to go red. A union C. A. Remember, union means the unification of both. And where do they intersect? Where A union B meets with A union C. So essentially, wherever we have the red and the purple. Sorry. So wherever we have red and wherever we have blue, wherever they intersect. So it's purple. See, you have to do this kind of stuff. If I was to mentally plot it out, because I was trying to mentally plot it out, I wouldn't have gotten this shape. I was just gonna put it in the center, and sometimes the questions are much more complicated than what we're doing here. So yeah, just take your time, plot it out. Okay. All right. So I think that's the answer. Um. Okay. Based on your drawings, do you think A union parenthesis B intersection C is equal to A union B intersection A union C? No. I would say they're not equal to. See, the thing is, that when you have the union of A with B intersection C, is that it's all of A, right? It's all of A, and in this case, none of them in the second part. It's it's the most connectedness between A, B, and C is just like the most overlap they have. But none of them contain the whole circle of A, B, or C. So yeah, this one's a simple no. They are not equal. All right, and at least that's how I read it now. See what the book says. Are the same for both. Wait a minute. If you do the drawings carefully, you will find that your Venn diagrams are the same for both. A union B and intersection A union C. See, I don't understand that. Let me see here. Well, the first part is agreed. That's the first one. The second one is, so we have A union B Okay, yeah. Where does that intersect with A union C? Oh! Oh my god. Oh my god, yes. It's right there. Just look at it, Oleg. Oh, how can I be this dense? Look, I actually have it drawn correctly. I just didn't purple it in. Oh my god, no. Yeah. Jesus. Oh my god. The next time, instead of I need to really review my work, because I always say, check your work twice, submit it once. So the answer is they are the same. Okay. Right. So there we go. I would say the journey in math is one of tentative steps and many stumbles. But that's okay. That's how you learn. It's not about getting it right all the time. It's about working your way through it. And that means getting it right, getting it wrong, getting it right, getting it wrong, but learning along the way. That's what matters. All right. So then here we go. But the process that I did with the shading was correct because even though I didn't shade in the purple correctly, it was clearly, I had it drawn correctly in the sense that the red and the blue both did overlap over the complete A. So, in other words, just do your work carefully and you'll get it. 7. Suppose the sets A and B are universal sets. Okay, they're in, okay. Draw that. So A exists in U and B. Okay. A and B exist in U. Okay. Okay. All right. So we're gonna say exists. All right. It's just gonna go like this. A, comma B are members of U. Okay. So basically, by the way, this notation we haven't gotten to it yet, but whatever. This says exists A and B sets. Now they're not part of the same sets. Let's just we could use the set brackets, but we're not going to do that because this is a set. In a sense, the A itself is a set with set brackets. So there exists set A and set B that are members of the universe, U, a universal set. Okay, so I just wrote this for convenience. Now we're gonna, because they give us a bunch of stuff, and I want to keep track of what's going on. Draw Venn diagrams for. Okay. Now we're gonna say for A intersection B. So in this case, right. So let's just go like this. If we're gonna do universe, I'm just gonna do a big sheet. Okay, so that's the universe. Now the only question is it exclusive to just did they complete the universe? Sets they are in a universal set or they are the universal set. See that it's not clear on that. I'll draw it both ways. So just to be clear, if you have a case like this where you're not sure what the question's asking you, like I'll answer both ways so that it can go. But you just ask your professor, even if it's on a test, it's fine. They'll give you clarification. That happens on tests all the time. So drive on for A intersection B. So we have A intersection B. And then what we want is a top. The component of the intersection. Oh, okay. No, this is a little confusing. All right, I think I just answered my own question. Okay, so when you start graphing like this, sometimes you can just get it right by just listening to the question. Okay, so we're gonna say A plus B is equal to U. If we establish that, let's just take this one out. We don't need that anymore. We say A plus B is equal to U. So then we have, based on what I just stated, the intersection of A and B. And then we want to say that's the component. So the component is not the intersection. It's like a not function. So just to be clear, it's not an inverse exactly. In other words, like, it's not just flipping the sign and making it the universe, because this is exclusive. When we say this, the component and the item it's a component of have nothing in common, meaning that they together combined make U. So we're going to say the whole thing. All right, so we're going to say the whole thing. This is going to be U, and this is going to be A, and this is going to be B. So the intersection right here, A and B is not active because we are doing the component. The component is everything that the other stuff occupies. It's not that. And when you add a component, we're going to say this. So just to give you a quick example. Let's see here. So let's say let C be a set in U. Okay, so we have C plus the component of C is equal to U. So, and basically that's how it works. They combine and form the universe. Now, sometimes it's a little different, but in this case, that's how I'm operating off this principle. And that's not what they wanted. I was close, but not quite. This is what they wanted. Okay. And then, so we have the component. So there we go. Now, the because what I wrote here, the set C plus its component represent the universe. They complete the universe. So when you say a component exists, then it represents things outside of the set. So meaning that it's things that exist in the universe but aren't part of the set unless you have a specific condition on the set. So in this case, we have the component of the intersection of A and B, and that means it's not just those two sets, but also the universe at large. So yeah, that's the answer right there. All right. Okay. Okay. So then we have the component A. So, okay. Second part. Say this is U. Second part. So we have A union B. It would be the whole thing. If we have A union B, they would merge. But then if we did the hold on. I'm sorry. No. We're adding the component of A. We're adding the component of A, unifying it with the component of B. So, oh, that would be this is an interesting way to put it. I gotta read this question some more. Draw Venn diagrams for the component of A union B, and component A intersects with component B. So what is the component of A as the universe? Which is outside of A. Um, the component is anything that's not in A. Um, and the component of B is anything that's not in B. So that's how it's supposed to be, by the way. That seems to me like the whole universe. But it's a union. I don't know. Let me just look at this one more time. Are they trying to make it be both things? So, oh, okay, right. Let's do these one at a time. All right, let's go with B for blue. Okay, watch this. The component of B isn't anything that's not B. Okay. Uh-huh. Uh-huh. Yeah, you see that? We just took a chunk of A. Oh, yeah. Okay, I see what they're doing. They're trying to teach us something here. This isn't just about answering a question. This is meant to show us the relationship and how we can flip between the two. That's the term for that, I think. We'll probably see that later. What? What? Page 1.6. Or sorry. Go to page 20 right now. Just go to page 20. It probably would not occur to us to say that Vladimir Putin is not in P. True, Vladimir Putin is not in P, but he lies entirely outside of the discussion of what is a prime number and what is not. We have an unstated assumption that P is a member of N, or P contains the naturals. What? Page 20, read it for yourself. Oh my god, that's weird. But totally off topic. I was just trying to find there's a rule. What was his name? I can't remember this. Hold on. There's a very specific way. It might not even be in this math book. No. I don't know. I can't remember the top of my head, but there's a some count or something like that. And we use it to flip between rules. And De Morgan, that's what it is. This looks like a De Morgan rule. And that's in 51. That's when we do truth tables. But this feels like it's a De Morgan law. Yeah, as a matter of fact, I would be surprised if this is not a De Morgan law. Meaning that it's the same kind of principle, I think. But again, too soon for that. We're not getting into that just now. Okay, so. Isn't that great? Math is crazy. Okay, now we're going to go with A, the component of A. So we're not touching A. We don't want none of that A. But we are going to take all that B because it's not in A. Oh yeah, this looks like a De Morgan law. Okay. So as you can see, the two match up. They're the same. And so in other words, if we do this, A, there. Yes. Cool. Um Yep, the book agrees. They were trying to teach us something there. It wasn't just like, this is really cool when they do that, where it's like they assume that you're smart enough to figure your way through something where the book doesn't explicitly state it previously. So that's cool. That's really good. Um, there we go. Just adjust my camera. All right. Hey, we're having too much fun today. All right, let's go to the next one. Okay, so we have draw a Venn diagram for A intersection B minus C. Okay, well, so let's see here. We're gonna go with A, B, C this way. So A, B, and C. It's an egg. C. Okay. All right. So we have C, A, B. Okay. All right. So draw a Venn diagram. Intersection of this is sorry. Intersection of A and B. Okay. Minus C. That's simple enough. So we have parenthesis first, PEMDAS A intersection B. It would be the whole thing. Taking C, C takes its cut. So that should be the answer. Book agrees. Yep. Okay, good. 11. We are flying along today. Isn't that crazy? Okay, following are Venn diagrams for expression write a corresponding expression. Cool. All right. All right. Okay, so you're going to be good at geometry and sets when you can draw good circles and good curly braces. As you can see, I'm just a student. Yeah. So 11, actually not. Let's dream a little bigger. Yeah. Okay, that's a little better. Okay, so we have A, B. See, this is in the book right now, and I'm simply drawing what they have here. And we have to write the equation. So we have, as you can see, it's B intersection C minus A. That should be the answer. It's the same thing as the top. They just rotate it. Look, if you take this and you rotate it, what is it like? One, I don't know, 135 degrees or something like that. And they go, rotated this, then you get that. You see how that works? So it's basically that's the same equation. And then we just had to replace where everything's located. So that was just a freebie they just gave us. All right, and 13. Okay, yeah. Okay, so now Gonna do shading. Okay, so as you can see, oh wait a minute. So then this would be a component. Let's see here. So we're gonna say, hold on. Let's assume everything is here. We're gonna say A union B union C, right? That's if everything is covered. And then we're gonna say that way. I think that's how it would be. I gotta think about this one. A union B will be covered, but we're saying it's not that, so it would be C. No, I don't think it's right. Okay. Let's see here. So we have. So this is something that exists in A, B, and C, but it's not. Maybe that was right. We're saying the component of something that exists in A, B, and C. So for instance, this little, hang on a minute. Let's just do a couple of things real quick. Let's just do some analysis here. So, all right. All right, let's see here. This will be blue for blue, A for red, and green for C. Okay, let's just do that. Makes a little bit more sense. So, if we say C union B, that would be all of this stuff. But we're going to say this, but it can't be an A. Okay. So we could either subtract or invert. I'm just trying to think what's the best way to go about this. If we were to subtract all of A, minus A union C, or we can do this, minus C. That should give us the same answer, I think. C union B minus A union C. No. What if it was C union B? Okay, let's just see here for a second here. Maybe that was right the first time. Okay. If we say that it's A union B union C, maybe I did have it right the first time. A union B union C, and then we're saying, but it's not that. So it's everything that contains. So if we say, if it's not this, that means, but that might not give us, I don't know if you could do triple like that. Maybe it would have to be A union B. I think that's it. That looks right to me, I think. So we're going to say everything. A union B union C minus A intersection B and intersection C. But I don't know if we can do triples in a row. I mean, we can do them in the next sets because we have we could have A union. Oh, here we go. Oh, okay. Answers my question. Thus, an expression such as A union B union C is absolutely meaningless because we can't tell whether it means. In summary, okay. So the idea, like, I'm going to throw some parenthesis around this. All right, so let's say A union B, and A union B is also in union with C. So that's everything. Now we're going to say with A intersects B, also has to intersect with C. So that's the only center. That's the only place where all three intersect. A intersects B, but also intersects C as the dead center. And if we subtract that, it leaves the hole in the center. But I'm going to throw another set of parentheses to really lock this down. That's how I think it should be. So one more time. If we have A union B, so let's just say here, A union B is the combined two circles, and then C joins the group, so everything's taken. And then we're going to say minus where A intersects C and also intersects B and also intersects C. That's the dead center because that's the only point where all three intersect. And then, so we complete that first, and then we take it out with the minus. I think that should do it. All right. Okay. Yes, the book agrees, and my answer was more thorough. What they wrote is this. But I'm kind of annoyed because this directly contradicts what they wrote on page 24. So basically, this is what the book. I did the same thing. I simply locked it down tighter. I went all straitjacket on it, and that's good because I wanted no ambiguity. Because here's what they said. The fact that this is 110. Compare. Blah, 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 blah. The fact that the diagrams are different indicates that A union B interunion C is not equal to A union B intersection C. Well, yeah, if you have like intersections going on in general. Thus, an expression such as A union B union C is absolutely meaningless because we can't tell whether it means A union B and intersects with C or A union B and B intersects with C. In summary, so basically, yeah, I think it's fine. By the way, if you put more parenthesis around something, you're just simply tightening up the order flow. So it's fine. Alrighty. That was 1.7. A little wild today, but we got through it. A couple of moments that I did not expect would happen. Okay, I'm just looking at 1.8 right now. Index sets. Mm-hmm. Mm-hmm. union of the first four. Oh, the union of all of them. Okay. So to mean the union of the sets A1 for 1, 2, 3 likewise. The union of the sets AI for I equal to 1, 2, 3. So we are unifying. Well, so this notation, index sets. Okay. Sigma notation, yeah. All right. Well, yeah, why don't you read page 25, 26, and 27, 28 if you want to be in the loop tomorrow. I mean, I'll explain it. I need to read it. I mean, I remember it generally, I think, because, I got fairly far in this book before I dropped the class to focus on work. And that was about maybe some months ago, not recently. Russell's paradox, good stuff. Ordered principle of the previous section. Yeah, okay, good. All right, well, yeah, and that's the other thing. Like, I go through the sections, but there's lots of stuff that like well-orderedness and things like that. I guess all this stuff will come up a lot more when we start doing proofs. But yeah, this is the type of book, even though I'll answer the question, there's still going to be so much more. It's just like it's something you got to really study and just soak in. Anyway, I'm just a student. I'm doing this to get better at math. All right, well, that's it for this stream. I'm going to end it, and I'm going to start my algebra and trigonometry stream. This is a class I did pass, this one here, not the sets, not the book of proof stuff, but I wasn't happy with how I remembered the stuff, so I am redoing the whole book. Actually, I passed through Calculus 2, and I will be doing a bunch of different other stuff. Probably maybe by this weekend, I want to start doing linear algebra and Calculus 1, probably. And then we'll see how that goes. Then I want to get into Calculus 2. It's because Calculus 1 and Calculus 2 are very different. Calculus 3 is building on a lot of Calculus 1 and some Calculus 2. All right. Well, that's it. Have a good night, everyone. Or just wait a few minutes and I'm going to restart my stream. Thank you for coming.